Alright, so today you're going to be watching this video about interaction diagrams. I'm going to use a couple of examples. You should be taking notes on everything that we're doing here, and then when you get done, I would like you to get together with a partner, somebody, discuss what you had there, make sure that you and whoever you're talking to are in agreement about how these things work, what you think. Tomorrow you're going to get an assignment on this stuff, have to do a bunch of interaction diagrams. So I want you to really think about it. Maybe even go so far as to come up with an example and then see if you can agree upon the forces of your example. So interaction diagrams, these are used to depict all of the interactions occurring in a large system of objects. So we've been talking about Newton's third law. Newton's third law of motion says that when any two objects interact, they exert forces that are equal in magnitude and opposite in direction on each other. Interaction diagrams are just used to show what things are in the system, what things are interacting. Okay. It's a very large system. It's not what we would use for a final analysis on anything, but we use it to start thinking about what are in fact the forces acting on an object. Because as we get into the diagrams here, if you don't have some kind of connection between two objects, then there's not a force being put on that object by something else. And so really it's just about trying to think about what forces are in fact acting on something. So we're going to start with the example here of the book on the table. We talked about this all hour yesterday. And for the interaction diagram, we'd start by listing the objects that are in our situation here. So we're going to have the book. We'll just kind of make that a thing. The table is a thing. And then we have the earth, which is going to be a part of our system there. And so we have these three objects. So every object that's in this large system, we give it its own box, circle. It really doesn't matter what the shape is. But then we start asking ourselves, okay, with all these objects, are things interacting with each other? Well, we spent all hour yesterday talking about the interaction between the book and the table. And so we draw a little line right there between those two. So they interact with each other. And we know that the book, because I did an example where I held it up and then released it, was attracted to the earth. And so we have that interaction as well. And then, of course, the table would also be interacting with the earth. Okay. We could, even if we wanted to get even more into analyzing this thing here, we could say the floor is maybe involved. And so we could put the floor over here. And there's an interaction between those two because the table sits on the floor. And so we have all of these interactions. Now, we know the names of a couple of different forces at this point. This interaction between the book and the earth, that is the force of gravity. And so you notice the notation there. Big F stands for force, subscript G stands for gravity. And then we introduced the concept of normal force the other day. So there would be a normal force experience between the book and the table. Remember, a normal force is a force that is always perpendicular to a surface. And so the force on the book by the table is always going to be perpendicular to that surface. Same thing with the force between the table and the floor. So that's a normal force. And then between the table and the earth, that's also force of gravity. By the way, in case I just don't want to skip over anything. For F sub n, F of course is still force. The n stands for normal, and so that's how we would mark that. Now, a couple of things here that I also want to talk about. The normal force is a contact force. that means that that force is only being exerted because there is physical contact between the two objects. The normal force on the book by the table is only there if the book is on the table. If we pick the book up off the table so that they're not in contact, then that force is not a part of the interaction diagram. But gravity is categorized as a long-range force. Long-range forces are forces that can be exerted on objects even though they're not in physical contact with each other. So because of the earth below us and the book, they're not in physical contact. The book is on the table. It's not in contact with the earth, and yet they still exert a force between them. Okay, Newton's third law. There's an interaction between the book and the earth. They exert equal and opposite forces on each other. So for things like gravity, you don't have to be in contact with the earth for gravity to take effect, but other kinds of forces have to be in contact. So pushing on something, pulling on something, if we had something hanging from a rope, a chain pulling something, those are all contact forces. Okay. Long-range forces, electromagnetic force would be a long-range force, and then force of gravity as well. So here's our first interaction diagram for the book on the table. Second example I decided to take from our comparing forces activity. We have carts A and B connected to each other. We have the track sitting on the table, or we'll call it the counter top this time, and then of course we still have the earth. So let's do an interaction diagram for this. We're going to have, well, let's color code it. We'll have A, we'll have B, and then I'll just use green for the other ones. We're going to have the track. We could have the counter top over here, and then we could have the earth over here. The locations of things in the interaction diagram really is not that important. I just like to kind of space things out a little bit so that it makes it easier to draw lines between them. So we know from the activity that there was a force exerted between carts A and B. Cart A is sitting on the track, and so is cart B. Those would be normal forces. The force between carts A and B is not a normal force. Remember, we defined that as anytime an object is sitting on a surface. So the fact that they were tied together doesn't make that a normal force. Okay, it's just another contact force. We'll just put an F there for that. We also know that the track is in contact with the counter. That would be a normal force between them. And then we could talk about the force of gravity being exerted between those two. There's a force of gravity here. We've got the force of gravity between these two. We've got gravity between the counter and the earth. And so we have all these interactions going on within this large system of objects. That's a lot of interactions, but anytime you have things in contact with each other or gravity, you're going to get a lot of different interactions. Okay, something's bothering me about this other one here. I suppose we could also say that there's a force of gravity between the floor and the earth. Can't escape gravity. All right, so let's make that complete. Okay, so that one's complete. We'll go back over here. So, like I said, what I'd like you to do then is just get together with another person, compare notes, see if you both agree to understand like how this works. And then, I know I suggested like maybe do this. I want you to do this, okay? Get together with whoever you're working with, create some kind of a scenario. It can even be just you and the other person sitting in your desks with your Chromebooks, and make that the larger system and just start putting in all the different objects as a part of that. Chromebooks, desks, you, your partner, the floor, the earth, and do an interaction diagram for that and just see if you agree on how that gets put together. Tomorrow, you'll get an assignment. The assignment has 10 questions on it, but you only have to do interaction diagrams for the first 5. 1 through 5, that's it. Do not do 6 through 10. Do not do 6 through 10, just 1 through 5. Okay. Work on those, make those interaction diagrams, and then by the end of the hour, I would really like you to also put together a whiteboard of one of the questions. So you can talk to the other groups, working groups of 3, and pick one of the problems, do an interaction diagram for it, and then we'll talk about those on Monday.